So it's almost lunch, and we're kind of hungry, so I'm just going to hop right into it. Today we're going to talk about marketing. What you're going to see up here right now is the classic conversion funnel. True story, I found this on LinkedIn. It has some points about how you can convince someone to kind of opt in and buy something. And I'm going to be using this conversion funnel right now to convince you why you should pay attention and listen to me. Well, you probably shouldn't. No, there we go. Okay, so what do? I'm an artist. My background, my undergrad was in fine art. I studied mixed media installation art, worked with a number of different systems while doing so, from the Arduino to embedded systems like the Beagle board, working with all sorts of electronic components, all the way up to software systems to build interactive experiences. I'm also a musician. I perform. You'll see me performing on Friday night when we do Dance.js. I studied music technology in my master's, studying the music system on computers, all the way from how we encode sound in audio codecs to how we create interactive audio applications to more installation art and just straight up performance, which is a lot of fun. There we go. I'm a developer. I have an open source graph, which is not as impressive as some of the people out there, but I'm pretty proud of the work that I do. I actually get paid full time to work on open source, which I'm super grateful for, and it's really great. Work on a number of different systems, bug fixes across all different things that start to get weird as you start coding more and more. You start to learn these kinds of things. I'm also a legitimate public speaker. Otherwise, I wouldn't be up on this stage right now. So why should you care about systems? So any given element of one system is simultaneously an element in an infinity of other systems. This is from a book called The Systems Bible by John Gall. I've got it right here. This book is really interesting. I found out about it recently in a thread between SiegeBot and Substack on Twitter. And I've had this really interesting way that I've been reading the book. Throughout it, you can't really see, but come and find me at some point during the conference and I'll show you. There's all these bits that have bold text. And it's just filled with wisdom. And right now I can show you, like, extra brain and tail wags on its own schedule. That's a pretty good systems quote. Another really great one. Let's see. The automatic pilot is not much help with hijackers. But so this is how I've been reading the book. I've actually been handing it off to people and randomly having them read it to me. And it's been really entertaining. It's its own system of how I'm figuring it out. But I'm going to sprinkle in some wisdom from this book as we go through and learn about systems. But one thing that's important to think about is that when we write code, we create systems. I often like to think of large software systems as kinetic art. Every piece in the system needs to line up perfectly for it to work. If any part of that system breaks, you're going to have a really, really bad time. This was a really important lesson for me to learn early in my career. Sometimes you can be writing absolutely perfect code, and it just won't work because the problem lies somewhere else in the system. As beginners, we often think that there's no way that we're that smart. Everyone else, all this code is kind of coming from the sky and it's handed down to us. But the scary part is that just because there's lots of code running doesn't mean that everyone who wrote that code knew what they were doing either. So how do you believe me? So we're going to start. I think I'm just going to give up on this thing because it's causing me more trouble than it's worth. But I'm going to start with an instructive anecdote. I work on an open source platform, and one day I came into work, December 1st, 2014, to this amazing GitHub issue. Basic demo fails in Firefox. Spinning Phi logo demo is wrong. It is spinning, but the size is also changing. It is decreasing to 0 and back to normal size and what it's running on. And so I actually, through the magic of versioning, have Firefox 34 running right now so we could see exactly what this bug looks like. It's not supposed to do that. This was my immediate reaction. So I immediately assumed that we did something wrong. I tried testing an older version of the seed project, which we've got going on right here, which worked. And then that really broke my brain. And the old one and the new one didn't work. So I immediately assumed that we did something wrong and we had some sort of nasty regression that we introduced into the platform. And at this time I was the release manager, so it would probably have been my fault. So I went directly into the CEO and CTO's office and told them that we might have to push a hot fix, that the sky was falling and everything was broken, and that I'd have it fixed before the end of the day, even if I had to stay until 4 a.m. And after about 30 minutes, it hit me that the difference between the two demos was that the old one was using a PNG and the new one was using an SVG. So it turned out that we didn't do anything at all. Our code base, it's got lots of its own bugs, but it wasn't a bug in the demo. It turns out that Firefox released 34 on December 1st. And Mozilla released it. And when Mozilla released it, they had this regression that got introduced to SVGs. And it was explicitly CSS 3D matrix transforms on an SVG were maintaining width. And it was just the weirdest thing ever. And yeah, that's so odd. And so we opened a Bugzilla issue, and I have a lot of love for Mozilla. They were really quick with this. They introduced a bug fix within 10 days, and by January 13th, about a month or so later, it was released in Firefox 34 and it was fixed. One of the things that's kind of challenging about this, though, is that for about a month and a half, anyone who was writing code against the spec in Firefox 34 would get a broken result. And I don't know about you, but I can just imagine that developer who thought of this amazing thing to do with SVG and they've never done it before, and they're sitting up until 7 in the morning because it just won't work, and they think that they did something wrong, but they didn't. The system was wrong. So another quote from the Systems Bible: as systems grow in size and complexity, they tend to lose basic functions. It's sadly true. So this brings us to where we begin. And what we're going to begin talking about is Chokidhar. What is a Chokidhar? Can I get any hands? Does anyone know what Chokidhar is? Anyone played with a Chokidhar? I see a couple hands. It's not one of these. For a while, you may forget what the name of the middle one is. It's Charmeleon. It's not Chokidhar. Chokidhar is a wrapper around the Node.js FSWatch and FSWatch file API. You may ask, well, why do I care about this at Browser Day? Well, it's because if you've ever used Watchify, Chokidhar is what Watchify uses for file watching. So if you're a Browserify developer, this is in your stack. You're dealing with this every day, and you very well could have had the same experience we had. But before we start getting into when I almost went mad, let's talk about why Chokidhar actually has to exist. So why do we have to wrap FS File Watch? It's because file watching on OS X is not POSIX standard. Yeah, I don't really know what that means, but I copied this, and I know a little bit because Forrest Norville sat me down and kind of explained it to me really nicely. But POSIX is a set of IEEE standards, and they're designed to uniform system-level APIs so that across Unixy operating systems, things are consistent. So something like reading files should be consistent against every flavor of Linux, but OS X decides to not exactly follow that standard to a T. This is a really great phrase, so I didn't think I knew enough about POSIX to give you something you could walk away with. But I didn't know how to pronounce it. I couldn't remember if it was POSIX or POSIX. But this phrase, I'm positive about POSIX, is a good way to remember how to pronounce it. But so Forrest at Dance.js, I believe, told me once that libuv wants to be pretty agnostic about making platform-specific, dealing with platform-specific nuances. So it actually is not in libuv to patch over some of the file watching problems that exist on OS X because of its non-standard compliance. So the consequences for this in FSWatch in the node layer is that file watching is only pull-based. You have to pull the file to see if there's a change instead of event-based. It doesn't report file names. It doesn't report events at all when using editors like Sublime. I don't know. I kind of want events when I'm changing code. It often reports events twice. It emits most changes as a rename event, which is not what you're always doing. It does not provide an easy way to recursively watch file trees. And then fs.watchFile is almost as bad at event handling, also does not provide any recursive watching, and results in high CPU utilization. So none of these are really great. So we end up with like all these layers, right? We have a native file system watching layer that's not POSIX compliant. We end up with a libuv layer that does nothing special for OS X. We end up with Node.js, which inherits the problems from libuv. So we create FS events, which is a native wrapper, which wraps the APIs that are exposed by OS X so that they can work the way they're supposed to. And then that gets wrapped by Chokidhar to shim the FS events when necessary. It's kind of crazy. For those of you who are having a seizure, this is a slightly better diagram for understanding what I was talking about. So you can see here, if you're a client to Watchify, Watchify is using Chokidhar for file watching. And then if you're on OS X, it's going to shim in FS events, which skips over Node.js and libuv and goes directly to the native file system watching standards. Otherwise, you go straight to the Node.js watching on Windows or on most flavors of Linux. So this brings us to another quote from the Systems Bible. Every picture tells a story, but not the same story. So let's go back in time a bit. Our team used Browserify and Watchify for like all the things. We use it for our seed projects. We use it for our internal tools. So when something goes wrong with Browserify or Watchify, like I find out pretty quickly. We also are using a lot of different modules because modules are cool. And we use npm link to wire them up. So you can see how these systems slowly start getting really crazy and complex. So if we're working on our platform, we'll npm link the platform into a module where we're actually creating stuff. And that's the way we can actually be like making changes and Git pushing and all that fun stuff without having to jump around a lot. The problem with this is this makes a ton of symbolic links. So one day, everything at work decided to stop working. Our developers came to me and are like, for the last week, I've had to restart the dev server literally every single time at some point, or I'm not getting changes. So it turns out that symbolic links just stopped working in Watchify one day on November 12th. That was a lot of fun. So I started doing research, and it turns out that symbolic links never worked in Chokidhar at all. There's an issue that's been open since 2012 to add it as a feature, and they're just explicitly saying they don't have it. But my team is telling me that everything had been working until about a week ago, so the anecdotes are not really lining up. And a few weeks later, it actually was figured out that Node.js made a change to the way that FSWatch and FSWatch file works so that it would actually like find the true path to things. So it actually worked by accident for a little while. So if you were using if you were not using FS events on OS X, which was the default in Chokidhar prior to version 0.8.3, then it just worked, but it wasn't supposed to. So now we've got this feature that we were relying on, but was technically never supported. So I created a little utility called Uatu. And I don't know if any of you are Marvel comic book fans, but this is the Watcher. So I created a meta watcher to watch all the Watchers. So Uatu was a test suite that wrote explicit like little watching commands like this. This was like the example of just going straight into FS events, where I tested changing files directly, changing symbolically linked files, and changing doubly linked symbolically linked. Wow, that's a hard one. Doubly symbolically linked files, because if you're npm linking, that's actually how it does it, because it links from the module that you call npm link into the global node modules folder, and then from there into your project. It's a lot of links. But so this test suite would go through and would run these tests against FS events. It would run it against Chokidhar. And I was able to pretty much come to the conclusion Chokidhar is definitely the one that is Chokidharing. It was around this time in the office that we would actually like constantly hear people screaming, Chokidhar! It's really, you should try it sometime. It's a lot of fun. But so I found a version of Chokidhar that worked, which was 0.81, by running this test suite. So I found a way to use the test suite along with git bisect to actually find the command that broke everything. So I don't know if any of you have used git bisect before, so I'm just going to explain really quickly what it does. Git bisect allows you to give Git a commit hash that works, and a commit hash that's totally borked. And then it will use a binary search to actually hop along your Git history, and then you can just keep flagging commits as working or not working. So since I knew a version of Chokidhar that worked and I knew a version that didn't, I was able to actually, and the irony isn't lost on me, I symbolically linked Chokidhar into my test suite, and then I ran git bisect in there, and I was able to just make a really quick script that would bop around and then find the last commit where the test suite passed. And I found it. I found the exact commit where everything broke, and I posted that online. And the current maintainer, I'm going to read this a bit, because this was actually the ultimate irony. What I found was not the bug I was looking for, but it was a bigger bug than anyone knew existed. What the Alpha Nerd has uncovered is actually a different issue. When there is a symlink somewhere in the path structure leading up to the project being watched, symlinks within a project tree did not get seamlessly followed before the commit either. Long story short, they're using an interesting way of doing cache invalidation inside of Chokidhar. And so when you were actually watching a file, you would say, hey, watch this file. And then when you gave it to the file watcher and there were changes, the events would have the full path of where it actually lived on the file system. So when it went to go into the hash to see like what had been cached, it just would always miss. And so you were just getting all these events that were going nowhere. And so this cascaded into like some really interesting stuff. So the first thing was this fix that we didn't think was going to be really easy ended up being really, really easy. And this feature that had been open for 2 years was fixed in about 2 days. With a single line in the package JSON, Watchify was working again. And we closed a two-year-old issue. But with a slight caveat, Symlink support is looking pretty good in the master branch, closing the issue. The Symlink specific test fail on Windows, but I suspect nobody is going to care. So for all of you who might be groaning, there's actually a bit of a joke here because technically there are no symbolic links on Windows. If you're an admin, there's kind of symbolic links, but I mean, yeah, it's ask Forrest. He knows more about this than I do. But so another quote from the Systems Bible, in order to succeed, it is necessary to know how to avoid the most likely ways to fail. And that's a lesson that I've learned the hard way a couple times. So what's important here is to not forget that you're always in a system. Everything that you're writing is living somewhere in this like massive crazy stack where people have made all sorts of decisions and they're not necessarily being made logically, or they may be made and be incorrect. The reason symbolic linking stopped working in Chokidhar was because it never worked. And then it turns out with when they refactored it, they never like followed that edge case because it wasn't part of the support matrix. So there was all these people who were relying on it, and the people maintaining the software never even knew. Don't forget you're in a system. Don't assume that you are wrong. Someone else is probably wrong. So I still have about 7 minutes on the clock, and there's another anecdote that I could talk about, but I'm assuming everyone's really hungry because we've been running kind of late. So I'm going to end a bit early and let everyone get into nomming. Again, I'm MYLES BORINS. I'm at the Alpha Nerd on Twitter. If you have any questions about systems, or you want to read me a section from the Bible, or if you want to hear my last anecdote, which has to do with why Mac OS X file systems are I'm not even going to get into it. Just ask me and I'll go nuts. But thank you so much, everyone. Have a really nice day.